Okie doke. They say the third time is the charm, so we're going to see if that goes with this one or not. Okay, guys, we've got 3-1, graphing systems of equations, also known as solving systems by graphing. We have a couple of examples here, just two, I believe. And then there's also a little summary guide included in your textbook that helps you determine the different types of graphing systems that we have. Okay. All right. So without any further ado, let's take a look at example 1. All right. So this, of course, is no fair because most of them are not going to be multiple choice, but it doesn't matter because you still have to graph it. Um, when you are given the equations in standard form, you are either A, going to find your intercepts and graph it that way, or B, solve them for y and graph using the slope-intercept form. Either way works, totally up to you. Where the two lines intersect is your solution. You need to present that solution as an ordered pair like they did here, not just x is -3, y is -2. You have to present it as an ordered pair. All right, so let's take a look at the one for your notes. Solve the system by graphing. We have x plus 3y is 2. 3x plus 3y is -6. Because I know it is the most popular among the students, I am going to solve for y. If, however, you are someone who really embraces the intercepts, then I encourage you to do that because I think in this case it would probably be quicker. But it's always a toss-up as to what method is going to be the fastest, and sometimes you don't realize what method is the fastest until you've already solved it the other way. Okay, so I am starting with equation 1, and I'm just calling it 1 to give it some identification. All right, so x plus 3y is 2. I want to get this y by itself, so I'm going to subtract x from both sides. This leaves me with 3y equals, I'm going to have that negative x term come first, and then plus 2. Now I want to divide everything by 3, and this gives me y equals, I'm going to write this as a fraction, -1/3 x plus 2/3. Okay. Now let's take a look at the second equation. And in this one, we have 3x plus 3y equals -6. So I'm going to subtract 3x from both sides again. And now we have 3y equals -3x minus 6. Now we want to divide everything by 3. And this is going to give us y equals -1 or -1x. I'm just going to write -x. And then -6 divided by 3 is -2. All right, so now, whoops, did not mean to do that. Let's go ahead and graph these two. Let's see if I can get this one back down there. All right, so graphing them. This one is not going to be too fun to graph, and I hope that you guys recognize that, especially with that being a fraction there. But it is not impossible. So we have 2/3, go down 1. Here, we're going to put the dot there. So we go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. All right. I stink at drawing lines on this thing, so please bear with me as I try. All right, let's see. Nope. Nope. I may have to cheat and use the line creator thing. We'll see. Okay, now let's go ahead and plot this one. We have -2, and this slope is down 1 to the right 1, down 1 to the right 1. Also goes up and backwards, and there we go. Here, this is where these two lines are intersecting, and that is at -3, +1. So they are intersecting at -3, +1, and this would be, oh, cry out loud. Oh, yeah, that's awful. um, this is going to be where these two lines intersect. I apologize for not being able to draw the line. I just can't do it. Um, and you have to be precise when it comes to these lines. Also, because you are graphing and I'm not having you do sketching, see, for crying out loud, I did put graphing paper there for you to use. All right, let's do one more real quick. Hopefully, let me see. Yeah, this one's not going to end up with any crazy fractions. All right, so looking at this one, solve for y, so we're going to subtract 2x. Y equals -2x plus 5. Okay, looking at this one, you're going to add x to both sides, so y equals x plus 2. All right, so graphing the red one, because that's what color I still have, the y-intercept is 2, the slope is 1. So we're going to go up 1 to the right 1. Now I am going to come down here and cheat with respect to the line just because it is rather embarrassing that I can't do that very well. Alright, and now this isn't even wanting to cooperate. Okay, there we go. Let's see, try to get that arrow. And there we go. Okay, so there's the red line. Now let's go ahead and take a look at the green line. So we go to 5 on the y-intercept, 3, 4, 5. Excuse me, and our slope is -2, so we go down 2 to the right 1, and there you go. That's where these two lines intersect, and that's located at 1, 1, 2, 3. So they're intersecting at 1, 3. Okay. See if we can make this green. I don't know if we can or not. We'll figure it out. There you go, guys. Now you can see it nice and pretty and proper. Okay? Okay, now let's talk about the different kinds of lines we have. We have an independent system, okay? And those are the ones that we have just done practice with. Those are the ones where you have a, excuse me, an intersection. You have a specific unique solution. A dependent system is going to be when you have lines piggybacking each other, for lack of a better word. And then an inconsistent system is when you have parallel lines. So this little summary box that we have in your textbook, super, super, super helpful when it comes down to it. So intersecting lines, it's independent, right? One solution. Coinciding lines, the same line, so same y-intercept, same slope, it's going to be dependent because it's the same line. And then finally, if you have same slope but different y-intercept, you have parallel lines. And there's no solution, and this is inconsistent. Okay? All right, so let's take a look at the final example that we have. And it says, classify the system without graphing. So what you're doing is looking at your slopes first. If the slopes are the same, then it's either parallel or same line, meaning it's either inconsistent or dependent. And then you look at your y-intercept. If they are the same, then it's dependent. If your y-intercepts are different, then that means that you have parallel lines and it would be an inconsistent type of system. All right, so loving these because this one is already solved for y. So I know that for equation 1, right, we have the slope is 3. The y-intercept is 2. All right, so now let's take a look at the second equation. Negative 6x plus 2y is 4. We want to add 6x to both sides. And we have 2y equals 6x plus 4. Divide everything by 2. And we have y equals 3x plus 2. All right, so now, second equation. The slope is 3. The y-intercept is 2. Okay, so slopes are the same. So it's either parallel or they're the same exact line. The y-intercepts are the same, so we know that this is the exact same line, which means that this is a dependent system because the equations, the lines are on top of each other. It depends on the other one. All right, let's take a look at the quick checks just to be on the safe side, make sure everybody's really good. I don't even know where to look at that. Maybe C. Let's go ahead and look at C. Okay, so this is equation 1. This is equation 2. So equation 1, solving that for y, we're going to subtract x. So x minus y is 5. We subtract x, leaving us with negative y is negative x plus 5. Can't have a negative, so we have y equals positive x minus 5. Then we have the second equation. We have y plus 3 is 2x. Subtract 3 from both sides, and you have y equals 2x minus 3. All right, so looking over here, my y-intercept, my slope is 1, and over here, my slope is 2. Because the slopes are different, right away, we know that it can't be dependent, or inconsistent, because those two must have the same slope. So since the slopes are different, we can automatically say that this is an independent, sorry, the marker got a little bit crazy on me, an independent, that doesn't even look right. So, you know what I'm going to do? I'm just going to abbreviate. This is an independent system. All right, kiddos, that's it. I hope graphing will be something that you guys find relaxing and a little bit of a review. Remember, when you solve it for y, you're plotting your y-intercept on the y-axis first, and then using your numerator of the slope to go up and the denominator of your slope to go to the right. Excuse me. All right, if you have any questions, please email me. Have an awesome one.